I just realized I'm the person standing between you and lunch, so I'll try to make this as compelling as possible, so you don't just walk out and go, oh my God, I'm hungry. So today's talk is about modern engineering practices, about how they're building blocks for the new digital economy, which sounds like a lot of really fancy words. But what this is really about is innovation, and not just the word innovation, but the practice of innovation. So I'll use an analogy. So let's say I wake up on Monday morning, and I want to be the world's best sprinter. I want to run faster than Usain Bolt. Let's say I want to do that. Big, audacious goal. So if I were going to do that, should I sit on one of those beanbag chairs and watch some videos about how to run fast, put on some of the running shorts that Usain Bolt wears, maybe a couple racing stripes, and then, after watching videos for about, 2 days, maybe having some snacks, go out and I'm going to run 100 meters in under 10 seconds. Is that going to happen? No, it's not going to happen. It's not going to happen. Innovation doesn't happen just because you install the things that look innovative. So all around Silicon Valley in California, United States, you'll find these startups that have a foosball table and a pool table and a beanbag chair, and they think that makes you innovative. No, it doesn't. It doesn't do anything for you. I find large companies that think innovation is about the rituals of innovation. It is not about the rituals of innovation. There's practices and techniques that it takes to actually develop things that customers find valuable. And that's what we're going to discuss today, or what are those kind of fundamental techniques that it takes to build products that customers will find useful and ultimately will be seen as innovative, and not just do innovation for the sake of innovation. That's what today's talk is about. So, really the first question is why now? Why is now the best time in history to be a software developer that can create innovative products that change the world? Why is it now and not 10 years ago or 20 years ago? So, you have a museum upstairs, and go see the old Mac upstairs on the 3rd floor. We have this museum in Silicon Valley, which shows these old computers that we used to have to use. In these old computers, who here has ever seen a punch card? A few of us, okay? Now, nowadays, if we have to reorder our code, we have syntax editors that tell us whether we have a syntax error as soon as we type the code. Imagine having to build a stack of 50 punch cards manually, which might take a day, and then schedule time on a calendar to run them into a computer that you had to run overnight, and then you find out you missed a semicolon somewhere. And that's your debugging process. It was a little bit harder when, your grandparents were writing software. It's a little bit easier for us now. But the bottom line is programming used to be really hard and really expensive. No wonder you didn't get a lot of new ideas. What happened before was the time from idea to cache was very, very long, okay? But what's happened since then is gradually the distance between concept to cache is approaching immediate. It's approaching zero. Now, back when computing started, in today's dollars, in today's currency, it would cost tens of millions of dollars to try an idea. Okay? Whose ideas get attempted when it costs $10 million to try an idea? Hint, not yours. Probably a government official. But over time, it's become less and less expensive to try ideas and take less and less time, gradually, of course. Then it was single-digit millions, then it was just hundreds of thousands. And then in the 90s, when we had the first kind of, at least in the United States, revolution of startups, you started being able to try things for $50,000. You could at least try an idea, see if it worked with a couple customers. You had an internet. You could promote the vast spread of ideas a lot faster. In the 2000s, this time frame became lower and lower. This is when Google really kind of started taking off and getting going. And you can actually try an idea. This is when, so in the U.S. we have incubators like Y Combinator and 500 startups that allow us to, you get $6,000 of funding, not very much funding, but with that you build the initial bit of an idea that will help you get your seed round. You're maybe $500,000, enough to build a demo. But now it's even smaller. Now we have the infrastructure in place. We have the tools and capabilities in place where if I have an idea at 10 o'clock at night for a big company, say I work for a retailer and I have a better way that I might want the search algorithm to work, I can go to bed thinking about it, probably not sleep very much because I'm excited about the idea, and then wake up the next day, program the idea, and then actually run it against, say, 0.1% of the traffic of a major retailer's website if I work for that major retailer. And then if I get a good result with that, say my search algorithm results in conversion, people going from the shopping bag page to the checkout page, results in that going up 10% with that small sliver of traffic, then I can then say, wow, that worked. That generates the business result I want. Let's start expanding the amount of traffic. And by the end of that day, and certainly by the end of that week, I, as a software developer with an idea, not the big boss, not the CEO, but the software developer with the idea, can then put that thing into production and create tens of millions of dollars of value for the company I work for. That's a fundamentally different kind of place that we come from before, where it was we had to do a project for 5 years to see the first little bit of value that we could create. So whose ideas are attempted? It used to be government, then the CEO, then the department, then the project management office, then the innovation department or the startup. Now it's you. And not just in your startup, but even in your larger companies that have adopted these practices I'm going to talk about today. And that's a fundamentally amazing place to be in our industry. So what is the thing that stops us from doing this? And to me, it's this artificial complexity. Artificial complexity. Now, we need a certain amount of complexity. My watch would not work with a certain amount of complexity to it, okay? I'm not saying have no complexity, but who here knows what this is? We call this a Rube Goldberg machine. So my first major in university was mechanical engineering. And the first thing I learned was, don't design machines that look like that. Don't design machines with more parts than you need. The more parts in a machine that are extra that you don't need, the more brittle it is, the more complex it is, the harder it is to maintain, the more way things can go wrong, the more bugs you're going to have in that system. The key to solving this, the key to being able to do this kind of change, this kind of 1 day, 1K type change, where we can create value, is simplification. That's really the key to getting this done. But simple is not the same thing as easy. And that's a key thing that I want to talk about. Simple is hard. Easy, we can create complexity without thinking about it. Simplicity is the art of taking a book that, they say most people that write a book, if you're going to write a 300-page book, you actually write about 1,000 pages of content, and they start deleting stuff until you have the simplest thing that can convey the idea. Simplification is the same in software. Who here knows Maslow's hierarchy of needs? Okay, a few people. So there's this basic idea that in order for us to feel self-actualization or the ability to reach our dreams, first we have to have food, okay? Food, water, air. If we don't have our basic survival needs set for us, we're not going to be able to think about how do we change the world. We're thinking about just getting food. We need food. That's our first basic biological set of needs. What's that? Wi-Fi. Yeah, food, air, water, Wi-Fi. Exactly. And people that don't have it will be panicking, right? But then we have, love, and then we have, belonging, and then at the top we have self-actualization. Same thing with regard to these practices. And the first level of this is engineering practices. We have to get the engineering practices right. So there's things that we do. So I'm a software engineer first, and I'm a business executive second. Is we have to actually get the engineering right. And now I could do an entire presentation on this, but one of the key things I'm going to talk about today is excess state. I have a shirt that I couldn't find, otherwise I was going to wear it today, that had the word setters on it with a circle and a cross. Setters are the moral enemy of software that has fewer moving parts and is simple. Okay, setters are this arbitrary, every now and then you need a setter in your Java code or your C# code or whatever it is. But a setter allows you to change arbitrarily the value of something inside of an object. As an engineering practice, setters are almost always bad. You should have a named method that changes the state of an object, and you should have state changes be very deliberate things. Setters promote this idea that state changes are not deliberate, that they're just things that randomly happen from the outside. And they create this kind of moving part in your code that becomes very, very dangerous. Null is one of the most dangerous concepts in programming. Why? Who here has ever worked on code and they're wondering what went wrong, and you see 3 or 4 levels of if-then statements, each of which is trying to is null. And you usually see yeah, you've seen it, and I think most of you have seen it, and you see a comment above that that says, bug number 475 solved by avoiding what happens when you're null, right? It promotes this defensive coding. And the problem is null means too many things at once. It means absence of something, or it can mean I just don't know what this is yet. The most strange thing in modern programming is the default state of any object in Java, in C#, in most non-functional programming languages, is the default value for everything is null, and null is the most dangerous value in modern programming. Which it's literally probably the source of half of the bugs you'll ever resolve in production code. Null is dangerous. Avoid it where you can. I'm not going to go through the rest of these, but these are all things that I think we've all seen as software practitioners that make code hard to understand, hard to read, hard to reason about. And we need to actually fix those things and use tools like Sonar and others like it that will actually help us understand where these problems exist and try to solve for that. So we're constantly coding with the sense of build simplicity. Make it easy for somebody to understand it, even if it wasn't easy to write when we started it out. So what are other things to fight this complexity demon, this complexity that makes our code hard to maintain and makes us unable to make these changes quickly in production? One of the most important things is test-driven development. People say we want test-driven development so we can do unit tests and have a big, I have 10,000 tests that make sure my code works. And that's great. But it's not the primary reason I do test-driven development. The reason I do test-driven development, where I write my test first and then write code to make that test pass, is that I actually want to make sure that every bit of code I write, I'm thinking about how it's going to be consumed first. Okay, just like I never write a feature in a software product without thinking about a user that's going to benefit from that feature, I never write code without thinking about what's the thing that's going to consume this code and how are they going to use it. And so I'm thinking about how it's used before I do anything. The other thing is functional programming. Functional programming, so languages like F#, Scala, Clojure, Erlang, Elixir. There's a reason why these are popular. And one of the biggest reasons is functional programming, and again, I do a whole talk on functional programming that takes an hour, so I'm not going to do the whole thing. But functional programming is valuable because it reduces the amount of state that you deal with. It actually has immutability in almost every major functional programming language as the default condition, where mutation or state change becomes a special case. In some cases, you can't do it at all. Like a language like Haskell, it's a pure functional programming language. It doesn't allow a state change in the way that you have object-oriented programming, in the way you have it in that particular paradigm. Others, like F# and Scala, you can have variables, but it's not the default case, which is really, really important, really, really, subtle. In object-oriented programming, we say, and it was a good idea at the time. I mean, when I was in university, I learned object-oriented programming. And I don't know how many people are in their 40s here that might remember this, but when we learned it in C++, we said, okay, well, we're going to have a typical model might be everything derives from animal. and then you have mammal and plant and so forth, and then you have different things that derive from that. We had these giant inheritance hierarchies in object-oriented programming. We thought that was a good thing. What it turned out is that it might be a good way to do biology, but it's a really kind of terrible way to do programming, because then we would have to wonder, okay, well, down in the platypus or some other kind of actual class that we're using, it becomes very hard to understand what code is actually executing when this thing runs. So that's one problem. The other problem is it encouraged us to do more programming than we needed. It would encourage us to build out these giant inheritance hierarchies of massive amounts of features without understanding how they're going to be used. Not to mention all the state change and other kinds of problems that object-oriented programming kind of led to. And so functional programming became kind of an evolution of that. They said, instead of trying to program an object model exhaustively, let's just kind of program about the things that matter to us, and then use these other tools to make state change and such less common, to reason about the part of the problem that we care about. So that's one of the biggest reasons why we care about functional programming. All sorts of other benefits to it. It makes multi-threaded programming easier and a bunch of other things that we care about. But to me, it just simplifies things. And that's the most important thing about it from my point of view. Another expression I use when we think about engineering quality is this idea that the code you write, other people have to maintain. So you should always imagine that the person that's going to maintain your code next is a psychopath, and they know where you live. They know where you live, and they're going to come knock on your door at 10 o'clock at night and bug you to fix something that you built. And that's the nice version of it. Or they might just come in and be mad at you and do more nefarious things. Okay? Always imagine they're a violent psychopath that knows where you live. Okay, that's the first level. Once you get the engineering practices right, I allow you to think about Agile. If you don't do Agile, or if you do Agile but you don't do good engineering practices, there's all sorts of problems. We'll talk about that in a bit. But so Agile is an old methodology. It's been around for 15 years. If you had a baby when Agile came out, that baby is now 15 years old and maybe driving. So that's how old Agile is now. It's not a new thing. But what's the valuable thing about it? It's this idea that we align our unit of work, the thing that we work on. When I wake up in the morning, I work on a user story, phrased in the manner of, as an X, as a user, in order to buy a product, I need a checkout button that actually checks out and allows me to process a transaction. Okay, that's one example. It aligns our unit of work to something users will find valuable. Okay, a counter case to this is I'm just going to build the data layer of something that's, like I'm going to build a horizontal set of cases. So I'm building the service that enables me to read the database. Okay, that's important, but it's not user valuable in and of itself. It's not something that a user can validate and say, yep, that's the thing that achieves some outcome that I care about. So our unit of work is a vertical slice, not a horizontal slice. And the key benefit of this, again, it helps us from writing lots of speculative code, right? Things that we think we need, but we're not sure, that add complexity without adding value, without adding things that a customer will appreciate. So, and I alluded to this earlier, if you do Agile, but you don't have good engineering practices, what you're doing is you're kind of doing the right thing from a unit of work perspective, but it's on a shakier and shakier foundation. So it's like, you're this house and we're removing these blocks from under it every time that we take a coding shortcut. Okay, and what happens over time is you have this burn-up chart that starts, you're doing Agile initially and it's really, really fast. And suddenly you find to do any story, it takes 2 to 3 weeks of effort where it used to take 2 to 3 days. And you're wondering, why am I hitting the Agile wall? It's because now every time we make a code change, we have to, regression test the entire system. Or, we get all sorts of bugs as a result of some code change because I change it here, but there's this other bug over here. Okay, that's why the engineering practices matter even more when you're doing Agile. Otherwise, Agile will slow down and become not a useful methodology. But it's evolved in the last 15 years. I mean, like I said before, Agile's old. It's 15 years old. So what's happened? So who here works in an Agile environment? Okay, a lot of us. Who here loves the iteration planning meeting? Oh, come on. It should be way fewer than that. It's painful. It's painful. You have to do all this stuff at once and prioritize everything. What if we could get rid of IPMs? Just get rid of them. Instead, we prioritize in real time. Every story that enters our backlog is prioritized then. If we don't have to estimate, which in a mature agile organization, you actually start getting away from estimates, okay? Because it's based, every story is about the same size. We get rid of the ceremony. We get rid of the IPMs. We pretty much just focus on having retrospectives. I mean, those are good because that actually allows us to improve our capabilities. IPMs, it's just extra work. Incorporating things like Kanban, this idea that we want to reduce the amount of work in progress at the same time. So we have a very fast flow of single features, not massive numbers of features that finish at the same time and become big batch releases. Another good thing is that how many people work in a company that says, I am a waterfall company? Nobody. Okay, one. Okay. Almost nobody, except for maybe one, does that anymore. Nobody. Maybe it's just because we've socially shamed them. Waterfall, it's like walking in and, smoking in a delivery room for your baby. It's a good time to do it, but maybe not then. It's not socially acceptable to be not agile anymore. So everywhere, we just call it like software development now. It's not even agile software development. It's just software development. So that's good. I guess that agile has massive uptake. The downside of it is it's the darkest corners of the industry are giving it a bad name. I go in a lot of companies that went agile 7 years ago, didn't get the results, and now they're like, I don't know what to do because even agile didn't work for us. And it's because they're not doing the right practices. And what's happening is it's being co-opted by people that want to still have the same kind of funding framework and the same kind of, we care about effort, not results. So things like scaled agile framework, Scrum, and other things, they take agile, they take the good parts of agile, and then they add all the ceremony of waterfall. So it'll be, in a scaled agile framework, we still have to have delivery gates, and we still have to have testing all at once and certain things like that. And they make it, a project management office. They make it friendly for the PMO, so they don't have to fundamentally change the things that they need to change in order to do effective product delivery, which is what I care about. I care about products that meet users' needs. I don't care as much about schedule and on time, which is shocking to a lot of people. They're like, how can you not care about schedule and on time? We'll get to that. But Agile gave birth to continuous delivery, which gave birth to DevOps as a culture. So who here knows what continuous delivery is and has read Jez Humble's book? And has read Jez Humble's book. Okay, a fewer. So this idea that we have this unit of work, right? We talked about it with Agile. It's a unit of work that users will find valuable. I built a user feature. We take that and we automatically deploy that to a set of environments that automatically configure and test the change. And so where we used to have to do all this work manually to take our change and configure it, we'd have to get, print out a document and take it to somebody that will allow the change to be controlled and so forth. We stop doing that. We say, okay, I write my code, I change the algorithm, it gets pushed up to GitHub, it goes into production, maybe not all of production, but maybe a little slice of production. It's configured, it's tested, and then we deploy that change to production if tests pass, and we just continually do this. We're constantly adding new features to our software instead of doing it all at once. That's what continuous delivery is. So why does it matter? Who here is a project manager or has been one for some time? Who here has ever remembered the term earned value? So earned value was this idea that we would say how much of the project was done based on whether developers said they were done. Which, sounds good, but turned out that so I did time as a project manager. And I remember this case where once the project was to 90% done, you really assumed it was only 50% done. Because the 90% would take the first 50% and the last 10% would take the next 50%. And so over time, I saw this happen, and I coined a term called faith-driven development, which is I have faith this much of the product's done, but I don't really know because I haven't seen it in production. I don't have evidence in a scientific sense whether this feature works. I just have everybody says it works. That's not good enough for me anymore. Not good enough. So that's one reason why we start doing CD is we want transparent evidence that software works before we claim we're done. The other reason why CD matters is we want to be able to quickly determine the cause of a problem. Who here has ever had to manage a production system? I have. And then you would do a deploy to production, and then you'd want something would go wrong. And the problem with big batch deployment is, how do you know what went wrong? So you spend all this time. You spend 90% of your time trying to figure out. We'll do these things in production and figure out where the issue is. And then you find the issue, and it takes you 5 seconds or 5 minutes. Oh wow, no, I had a null pointer reference. Okay, fine. Okay, put a little block of code around the null pointer to ignore the null pointer or something. Once you spend all the time finding the cause of the problem, you spend very little of the time fixing it in production. That's usually the easy part. With continuous delivery, if you have a right kind of test framework, if something went wrong pretty quickly. And because you didn't put very much production, you had one change. You changed 5 lines of code in the last release. So it's pretty obvious where to look when you're trying to resolve an issue. And that's the big change. We're doing a little bit at a time, and we're knowing when problems come up in real time rather than all at once, where it's very hard to scientifically figure out what actually happened. So the other thing you do is you get feedback faster. So you avoid deployment of large bundled features that users don't value. This gets into making software simpler. Okay, so hypothetical. If I'm running, say, a large travel site like Expedia.com or something like that, and I put out a big release with 50 major features in it, and let's say conversion goes up, which conversion means, from the hotel search page to the checkout page, how many people actually click checkout so that I know how much money I'm making, okay? If I did 50 features at once, how do I know which of those features actually created the improvement? Correct answer is you don't know, because you've got 50 possible candidates. It's impossible to know which of those things created the value. The thing we get out of continuous delivery is now that we're putting out features one at a time, and if we have metrics around those features, so we know what our conversion rates are, we know what our usage rates are, we can measure what the software is doing and how customers are interacting with it, we can understand what features add what value. And the most important part of that is if there's features that don't add value, we can remove them, which makes our software smaller, which makes our code base smaller, which is a good thing. We want smaller code bases. We want the features that users want, and we want to eliminate the features that users don't want. So it also brought up this idea of DevOps. So sometimes, and you'll see it in a lot of companies where they say, I want a DevOps person. I'm not sure what a DevOps person is. I'm still not convinced that's a real thing. In my world, there is no such thing as a DevOps person. DevOps is a culture which is an aligned set of incentives. It used to be developers would just push lots of features out, or always demand operations people push lots of features out, because they're incented to do that. I'm a developer, I'm incented to get things done. Operations, traditionally, was incented to manage uptime. And what's the best way to manage uptime? Make sure no changes happen. So, dev, I want change. Ops, I don't want change. And you wonder why the two often fought. Usually in meetings where they would yell at each other. And so something had to give. And what happens is if your incentives are about getting features done on time and your incentives are about creating uptime without a real business incentive, those two things are always going to be at odds. What DevOps is about really kind of having a common set of incentives around business results and not other kinds of things that matter in isolation but don't matter to the company overall by themselves. So, what happened as a result of the DevOps movement? Once we're forced to do this stuff together, we started thinking about things a little bit differently. Who here has used Chef, Puppet, Ansible, or something like that? Who here still manages a server manually and clicks things to configure a server? Nobody. That's good. That's good. This has been one of the most important innovations of our time, is just the ability to, when you set up a new system, you do so automatically. Certainly within ThoughtWorks, if we if you have to manually do anything, the first thing we're doing is figuring out a command that allows us to do it somewhere so we can repeat the process. So we don't end up with what are called snowflake servers. Who here knows what a snowflake server is? Okay, not many? Okay. Or cattle versus pets. Anybody know that analogy? Okay, a few. So let me explain the cattle versus pets analogy real quick. Pets have a name. Who here has a pet dog or cat? Okay. Who here has ever worked on a farm? Okay, there's a reason why you don't name your cattle. Because once you give your cattle a name, now you're personally attached to it, and you're not going to turn it into a delicious steak. So that's the problem, is that once you have a pet, pets have names, and you're managing the pet name server. Okay, and now it requires special knowledge to know about that server and what it's doing and how it's configured and whatnot. What we're doing with Chef and Puppet is we're doing something called Phoenix deployment, which is when we need a new version of the server or we need an additional copy of the server, we destroy the old one, we burn it to the ground, and we create a new one. So what happens is we're not like hot patching the servers. We're just literally, if you can't automate creation of it, in my world, it doesn't exist. That's why we do things like Phoenix deployment using infrastructure as code. Okay, if your infrastructure isn't able to be recreated from a script, in my opinion, you need to fix that. The other main innovation we get out of the DevOps movement is containers. Containers are amazing. So who here has used Docker? Awesome. I love that everybody's using, or at least a lot of people are using Docker now, or other things like CoreOS that enable things like Rocket. The cool thing about containers is it gets us out of this thing, web config, which is like a nightmare. The problem with server operating systems before containers was people thought the more features you had in your server operating system, in your Windows 2012, in your Solaris, whatever, the better the server operating system was. What we've realized with containers is that actually your server should have as few features as possible. Should have fewer features, not more. This is why there's a Microsoft Nano server now. Who thought Microsoft Nano server would exist before containers? It's amazing that it does. But to me, it's a victory of this idea that we want an operating system that does exactly what we need it to do. I need to be able to serve network requests. I need to maybe not write to the file system. And that's it. Those are the things I need 99% of the time in any service that I'm writing. And that's an amazing thing. What happens when you have fewer features on the operating system? You get better security. Because the more features an operating system has, the more potential holes from a security perspective you also have. And those holes become the ways that hackers get into your system. And so if you have fewer of those, I mean, they can still get in, but it's much less likely that they will. And that's what we're shooting for. Make it less likely that they'll get in, because you can't ever 100% secure a system. So the other thing we got out of the DevOps movement is this idea of microservices. Small stateless units of business capability that do one thing well. Smaller code bases, typically RESTful, usually 1,000 lines of code or less, so there's fewer things to interact in the first place, fewer sources of confusion, fewer moving parts. They tend to be stateless. They tend to be just kind of like web services where you call something, it goes to a database, grabs something, and returns it. You're mostly doing transformation. You have very few long-lived objects. You have a lot less need for state. So therefore, functional programming becomes a lot more realistic. And they can be deployed in containers that isolate the environment in which the service runs. It runs in a container that doesn't do a lot of things. A lot of times you have this idea of sealed containers that you never bash shell into. You just deploy the container, so you write into the container to deploy it using Chef, Ansible, Puppet, something like that, and then you put it into production, and that's it. It's beautiful. And then if you ever have to recreate a new one, you create it from scratch. You never configure it. It's literally immutable. So now we have this thing called serverless. Who here has heard of serverless? A fewer number of people. Guess what? There's still a server involved. The real name for this, I call it nano services. It's things like Amazon Lambda. Google has Google Cloud Functions in alpha now. But they're, instead of a microservice, which might be 1,000 lines of code, it's 50 lines of code or fewer. It's literally a function or a small collection of functions that are put out to production. And you run them entirely in a cloud environment where they're almost required functional programming because you never have long-lived state. And they're not deployed in the traditional sense. You put it up to Amazon, and then Amazon or Google or whatever the cloud platform is kind of spins up a container right at the time the function is called and destroys it right when it's done. And so literally you never, under nanoservices, the reason you call it serverless, is you never think about the infrastructure at all. The infrastructure is completely disposable. There is no server to maintain. I mean, there's still a server. If Lambda goes down, you're out of luck. But the chances of that happening are a lot lower than your server going down. That means all of Amazon goes down, which would be kind of catastrophic for everybody, I think, at this point. So, Agile and CD, getting the linkage between these two. CD can't happen without Agile. Your unit of work has to be something useful for CD to be meaningful. If you're continuously delivering things that aren't features, it doesn't make sense. And then being able to have the engineering practices that Agile depends on is what allows you to do continuous delivery. If you're continuously delivering bugs because your engineering practices are bad, nobody will let you do continuous delivery. So what blocks CD acceptance? One, it's just kind of fear. We're used to big batch releases, and we confuse continuous delivery of buggy software in big batch releases, kind of the traditional, what happened when you did a release, the disruptiveness of it, with what would happen under real continuous delivery, where you're delivering small bits of functionality a little at a time. A lot of companies have audit concerns, and this could be a legitimate thing. I've done work for an airline where you have unions in the airline, and the union has to approve every code change that goes into production for a good reason, because it was scheduling workers in the union. So, they had an audit procedure, which is fine. You can still do audit procedures with continuous delivery. You just have to have a much more, you have to have an auditable, so, somebody's approving that new feature going in. So it's not the developer just writes the feature and it goes into production. You have somebody that, goes into test and QA, and then, somebody who's the right representative will say, okay, this is a good change, and they put it in production. But it's still frequent. It's still, once a day or once every couple days or once a week. It's not this big thing where you have to release once every 6 months. This other problem is the confusion between the frequency of change and the scale of change. If I give you a new release and it changes everything about your software, it means you have to go to new training. That's a disruptive release. Google releases new versions of Google all the time. We don't think about, I got a new version of Google. No, Google just works and improves a little bit over time, very slowly but very consistently. So why should we care? Again, this large batch problem. The problem with large batch problem is that when you're developing under the traditional methods, you don't know what features are good or not. And for every one useful feature, a Forrester report showed we're actually delivering 5 that aren't useful. And so we destroy millions of dollars of value. We spend a lot of time developing software that users don't care about because we don't do continuous delivery. So in a world of continuous delivery, we're actually measuring our delivery by what actually works, not just what the project manager tells you. So there's transparency in what we're delivering. But that's not enough. So it gets us to this idea of lean startup and lean enterprise. So think about this for a second. What is more valuable, a Tesla or a completed project? This is the one way I frame products matter. Projects are a means to an end, maybe, to get to products. And we should, if we can, think about products over projects. So we already have DevOps, right? Now, DevOps is just developers and operations. But we don't exist in a vacuum. There's also business and product here. Business has a reason why they build products, and products, technology products are delivered through development and operations working together. So why don't we just cut it and just call it BizOps? I mean, this is literally the way that we put business results into action, is through technology in the modern era. So there's the new term, BizOps. It's the new DevOps. And this idea is DevOps isn't enough. So one of my colleagues wrote a book called Lean Enterprise. Actually, 3 of my colleagues did. And the idea is you have this, you start with kind of a vision and goals and bets within the company. And this is how it's a way you reorganize your project management office around results instead of effort. And so you build a product strategy. You still do strategy. You still have to choose whether we're going to sell, clothes or shoes or airplane tickets. I mean, you still have a strategy. But then you design a portfolio of things that are hypotheses of value. If we do some analytics around how we personalize the experience for a customer, maybe we'll get more conversion. Might be a hypothesis. And there's a lot of other ways you could look at that. And then you start thinking about product architecture, this actionable thin slice. How can we test our hypothesis in the simplest way possible to get feedback very, very quickly? Okay. So it's running a little bit long. I'm going to go really, really fast. So we have the lean value tree. The bottom line that I want to get to is results matter more than effort. Results are the things that matter. So is the monolith dead? We're creating a revolution. We're going from code bases with millions of lines of code to code bases with tens or hundreds of lines of code. We're going from big iron, big server farms, mainframes, whatnot, to private clouds, to disposable infrastructure. So we don't even think about the infrastructure. It's just a thing that we can deploy code to, and we recreate it on demand. We go from projects where success is on-time delivery to results delivery. Like I said before, I don't care about on time and on budget. I care about solves a customer's problem. We go from software developers as an organizational cost, and this is the best part of it, to software developers as a driver of profitability. In most companies, the salespeople are the ones that are paid the most money. Why? They're the ones that make the money, right? They're the ones that have a revenue goal. And I'm a salesperson. I must make $2 million of revenue. And because we can measure what they do, they can get more money because there's a direct connection between what they do and the money the company makes. Software developers are now in that position. If we do this right, because you can test a change that we put into production, an idea that I have on Sunday night that I put into production Monday afternoon, we become the drivers of profitability. We become the people that obviously create the value in our companies. That's an amazingly compelling position to be in your industry. That means you're going to be the people that create the value, not just the people that play golf or take the other executive out to a steak dinner. It becomes you now. So, what do you walk away with? Go watch this talk, Simple Made Easy. Rich Hickey, creator of the Clojure language. This is a great talk if you want to dig into the topic of engineering practices and how they matter for building software that matters to users in a way that's maintainable. Probably the best talk I've seen in 10 years on this topic, and probably will be the best talk you'll see in 10 years on this topic. So just Google Simple Made Easy, and you'll find it. And then the books, Lean Startup. The first book I read in 5 years, where I got my highlighter out and started just highlighting the parts that were just really, really evident. A lot of these ideas are drawn from Lean Startup. My colleagues wrote Lean Enterprise, Jez Humble, Joanne Molesky, Barry O'Reilly. Talks about how do you apply this in larger companies. So Lean Startup, for those of you in startups, just stick with that. If you're working for a big company or you're in a consultancy that works for big companies, Lean Enterprise helps you understand Lean Startup, but in a context that has audit and other kind of big company concerns. Continuous Delivery by Jez Humble, kind of the book on the topic. One of my colleagues, Sam Newman, wrote a book called Building Microservices. One I'll add to this is a book by my colleague, Keith Morris, called Infrastructure as Code. Also a good book you should read on this topic. And then my book, Nomadic Developer, I just put it here because my publisher makes me put it in every talk I do. Don't worry about that one. Thank you so much.
Thank you. Thank you, Aaron. During your presentation, I invented new measure for talks and value of a talk. And I think we already reached about 80%, and the rest 20% will come through the Q&A session. So questions?
Any questions?
We have a few minutes for questions, please.
You said from the start that Agile for 15 years, maybe even a bit more. But don't you think that in the last few years, all these Agile things, all this talks about flexibility becomes a bit more religious than IT stuff should be?
So can you repeat the question?
It became a bit more religious. It's kind of religion talks than it should be from IT staff
Yeah.
perspective. We talking about all these agile things, flexibility, simplicity, like religion, not the technical stuff.
Yeah. So what differentiates a religion from science is the ability to test things, the ability to test your empirical framework. And where I got was when I was actually delivering software for a company, and I was actually able to see the value. Saw a company that was struggling, and then we made a change that went into production that raised their conversion rate by 80%. That made it less religious for me at that point. It made it much more about practice. And I think that's, yes.
We have lunch for discussions.
When we're talking about moving from standard architecture to serverless, could you please provide us with some example of maybe medium to large projects which already use serverless in production?
I can't because almost nobody does. It's really new.
Any question?
But
from
it's
this
really
side?
neat. You should explore it. It's super alpha though. So yeah, probably somewhere in Amazon. I'll bet you half of Amazon runs on it. And you don't know it today.
Thank you. So we deliver our software in boxes, and each time we have a release, we have to ask our customers to make an update. So what you would suggest us? Any?
Don't deliver software in boxes.
It's not possible to deliver outside of boxes. So
Fair enough. Fair enough.
any methodologies like what you advise?
So try to make it the least or the most frequent as possible. And there may be ways so you could deliver in boxes, but a lot of software now, even updates come very, very frequently that can be downloaded for kind of minor updates, and then the major updates are box. So like think games, for example, right? Games, operating systems, certain kinds of systems require that you release it all at once. You don't release the first 10% of a movie out to theaters and then get the next 5% and get the next 5%. So like everything, it's an 80-20, right? There's 80% of software. It's better if you can, but if there's hard audit concerns or you're delivering into certain kinds of cases where you just can't, try to create some kind of mechanism for feedback otherwise while you're in the development process. Because what's important is the feedback cycle. And if you have no feedback cycle, then you have to hope Steve Jobs is your boss. Because he's one of the few people on earth that's brilliant enough to create a product all at once that will just automatically get user uptake, and you don't have to kind of rely on faith and hope that it's good.
Questions?
Pass the microphone back. Yep.
You speculated about oh, how do I know that the project is finished, the feature is done, and so what's your definition of that done?
My definition of done isn't in production. It isn't dev done. It isn't QA done. It's I've generated business results done. So I've measured the impact of the feature, and I know I've made money from it. Or I've added value for a user in some way. That to me is done. That's my definition, yes.
On the amount of money, probably.
Yeah, it could actually help you lose money. If I put a feature out there that actually drives users away, that might also be done by pull it out of production as fast as possible.
Aaron, first of all, thank you for great presentation. I would like to ask you about best recommendation, how to transform, for example, if company is using like old methodologies and how it would be, what would be less painful way to transform to all those new technologies for the company?
So I think the best way I've seen is to actually co-develop with people that have done it. So if you find that there's groups of people that have also done this before, that have been pioneers. We have this strategy where when ThoughtWorks is asked to do one of these things, we'll take one team that's kind of bought into the methodology but isn't doing it yet. It's a pair. So it might be 5 of their people and 5 of ours. And then we deliver something super valuable to the company using that one team. And then we do something called split and seed as one of our main techniques, where we say, okay, now we've got 5 of your people and 5 of ours. Now we can go into the next 3 or 4 teams and do the same thing, but maybe with a slightly lower ratio. And start So what we're doing, instead of saying from on high, you must do this methodology, we're spreading the methodology team by team, but in a geometric way. So it's 1 team, then 2 teams, and 4 teams, then 8. And we're starting with the most valuable stuff. So not everything is as valuable. If you start with something that's going to create a real impact for the business, that creates the momentum required for other people to voluntarily want to buy into it instead of being forced to buy into it.
That is actually the question: how we can break existing paradigms in brains of our in our teams and just convince them to go to the right way.
One on one. There's no there's no easy way. It's winning hearts and minds. It's the art of politics. It's not the art of development. But that's why we have to admit it's politics and go as such.
Okay. Yeah. We're approaching lunchtime. This is probably sometimes is the most productive time for discussion, because those who have questions but afraid to ask in a big auditorium can approach Aaron and ask the question personally. Aaron, thank you very much for such inspiring talk.
Thank you.